Thank you for being brave and staying here like the talk before the last one. I'm Pere, and I'm going to tell you some stories from dealing with Apache Kafka in the trenches. I work as a technology architect for Confluent. As you notice, my accent is not like very German. I came from Barcelona. So I'm not either a native English speaker or a German speaker, and as well as being accused way so many times of speaking way too fast. So please bear with me, and if I speak too fast or whatever, just do the international sign of slow down. Sorry. So what we are going to see today is mostly a short revival or review of Apache Kafka internals and a lot of stories about what to do and what not to do on Apache Kafka. First of all, how many of you know Apache Kafka? Okay, majority. How many of you actually use Apache Kafka in production? More than 3 nodes in production? Okay, quite a lot of brave people. So the initial part might not be so interesting for you. However, it's good to set some basic knowledge around. What is Apache Kafka? Apache Kafka is basically becoming this central piece of infrastructure, of setup that lets you connect your databases, your data warehouse, your streaming applications, a little bit of everything. And it lets you, for example, connect your relational database with Elasticsearch, to build search pipelines, with your data warehouse to store, build your data lakes, etc. This is becoming, it's actually a streaming platform. Okay, it's a platform that lets you connect from systems into another systems, that lets you produce and consume data, and that lets you enrich and process that data. So in Apache Kafka world, we have the connectors. The connectors are plugins or are small pieces of software that let you read from, for example, from a database and inject this data into Kafka, or let you read from Kafka and write this data into, I don't know, things like HDFS, S3, another database, etc., etc. As well, there is the classical producer and consumer APIs. That is the initial clients for Kafka. And last but not least, there is Kafka streams. That with Kafka streams, we can read and process in real time from topic to topic, basically allowing us to calculate aggregations, filterings, etc., etc. Last but not least, it's very important to remember the traditional structure, or like the bare bone structure in Kafka. So this is basically a log. Everybody can understand a log, okay? We can have many readers in different places. We can have, we always write to the end, always append only, okay? With this in mind, we can build a lot of abstractions. But this is not a talk about what is inside Kafka, it's a talk about this, okay? Kafka is a highly distributed system. And that's where the fun part begins. In here, we have the partitions, where we can have leaders and followers. We have the brokers, that it's an abstraction on top of these partitions. But we as well get our dear zookeeper, okay? That is here to allow all this coordination to happen. But not least, we have small components inside this infrastructure. We get the controller, okay? The controller is the thread responsible of organizing the communications with Zookeeper, responsible of saying who is the leader for each partition, who is the follower. It's responsible of organizing, basically tidying up here. Should be only one controller in your Kafka cluster. If you get more than one controller, something wrong is going on. Winter is very bad. You have as well the log compaction threads, or the replica fetcher threads. The replica fetcher threads are responsible of actually running the replication. And the log compaction are the responsible of shrinking and compacting your threads, as well as deleting all their threads when the period is over. The consumers get grouped in a consumer group, okay? So consumer group is basically a bunch of consumers that work together. And as well, we get the producers. A lot of moving parts that sure will make our life very interesting. The idea of Kafka, or what it brings, is a scalable production and consumption. By scalable production is because the producers can write to as many partitions as they want, or need to, because there is a hash algorithm that lets you decide to this producer which partition is actually writing to. But as well, the consumers that are grouped into the consumer in this consumer group are able to scale the reading from each of the partition. This slide is very, very important, okay? Do you know the idea of this, the anatomy of a request? This is actually internally in Kafka, okay? What is actually happening here is it shows you from the network threads, from the network ports, sorry, the threads that are responsible of fetching this request, and then, all the way down. So there is a bunch of network threads that reads your requests from the ports. Then it goes to a request queue. From this request queue, there are I/O threads that fetch this request and write to disk whenever this is necessary. Actually, not write to disk, write to the page cache, but this is another question. After that, these same threads pull this request to the purgatory. The purgatory is the intermediate stage where your requests are living until they are being synchronized to the other brokers. Okay, so for example, if I have ACK equals all, that we're going to see later on, the request is staying here until all the replication is being made. After they are past the purgatory, they go to the response queue. Why I'm showing you this picture is because all of this is being monitored by JMX, we'll see later on. But if something goes, for example, wrong in the I/O threads, stuff gets piling up in the request queue. And if the request queue is causing problems, network threads are going to be busy, as well for the response queue or the purgatory when the communication goes to the other brokers. Okay? If you are seeing a funny behavior in Kafka, this image is going to be very useful. I always say that you should cut this slide and put it in your desk, because it's always very interesting to have. This is the very same picture, but broken down in components, okay? Where we see the replica manager, that's actually the manager of the replica threads, what it's doing, if it can complete, delaying the operations, or writing into the partitions, okay? With these two slides that we have seen, we can actually analyze what is happening internally, okay? And if we see idle or not so many idle I/O threads, we see that the I/O stress is bigger than, probably more than what we resist. After having reviewed the internal components of Kafka, let's start by reviewing the challenge. Do you all understand durability and the guarantees that Kafka is providing you? Are you all comfortable with that? Nope. Let's see the first challenge. Understanding them is very, very important. So in a wonderful scenario, in the perfect world, a producer sends a bunch of messages, the partition leader receives them, is able to update the open segment. If we have more replicas of this partition, the high watermark protocol kicks in, and all the data is being replicated, and no exception is being returned to the client, and more production can continue. But bad things happen in distributed systems. Otherwise, would not be fun to work with it. Imagine this scenario where we have a producer that sends a bunch of messages to one server. This producer, always good to remember that it buffers messages. Okay, so all the messages that I sent to the brokers are being grouped for performance reasons to the server. In this producer, we can define some ACKs guarantees, from fire and forget to please remember everything. But in that case, what happens if this broker goes on fire? Oh no, my data was only in one server. You are all thinking, I'm not going to do that. You are not thinking, I'm not doing that. Still, many people ask, can I have only one broker in Kafka? And I say, yes, but at a cost. If the broker goes on fire, you have a problem. Let's say you have moved from the first stage to the second stage. Now you have 3 brokers, okay? Where you actually have many partitions, some leaders, some followers, and they have to use this very same producer who sends with different ACKs. The ACKs is the variable that is responsible of defining part of the guarantees, okay? By ACKs, it means how many replicas have, how many partitions have to get your message accepted, okay? In here, if we imagine, for example, ACK equals 1, only the leader will get the partition. Will get the write, sorry. Without waiting for replication. We can have different variables to work with the guarantees. One is the ACKs, another is the replication factor, okay? How many replicas do we want for each topic? And as well, one that's very important, the min in sync replicas, okay? If we get ACK equals all, that means all of my replicas have to be responding. As I got the message, I got the copy. The min in sync replicas is telling you how many of these replicas have to actually be responding. What defines all? Okay? Imagine this situation. I read here, first got the message, got replicated, everything is fine, I get replicas. If one of the brokers gets problematic, gets offline, if I get these 3 replicas, I can still work because I will get one of the replicas in this broker, but it depends on the min in sync replicas, okay, that I have. It can happen that, for example, if 2 brokers goes offline, or in the case of the 2 brokers, it depends on the min in sync replicas, that the topics goes completely offline, so you cannot write anymore. Because if you ask Kafka to be completely warranty on that sense, yeah, it will tell you, no, sorry. You should be careful when you start with Kafka because the defaults are not production ready. Because it's very hard to have a production system in your laptop. The defaults are 1, 1, and 1. What it means is that Kafka is optimized for availability and latency. Okay, it's optimized for fire, received in one broker, and return, not for durability. Okay, if we want to work with durability, we need to work through replication. Okay, durability in Kafka is achieved through replication. The idea of having a sync to disk is very expensive, so yeah, it's done through replication. As I said before, we have we say ACK equals all is equals to fire and forget. Very nice, very fast. However, it's unreliable. It could be that the replication is not being actually executed. ACK is equals all in the producers is super resilient. However, it comes as a cost. Okay? Because you need to wait this request that all the replication is being executed. For the brokers, please think how you set min and sync replicas. Okay? The min and sync replicas should always be n-1. Okay? So it can be always n, but at the minimum should be n-1. If you get 3 brokers, have 2. If you get 4, have 3. You can have more, obviously, but you need copy of the data. If you have the replication factor for a less for something that's reasonable, should be a less 3. Okay, because you get 3 copies of your data. If you are working with a stretch cluster where you have 2 data centers, just think and remember to have data in every data center. Okay, so work with multiples of 2. The second challenge is to understand the replication, the under-replicated partitions. Because partitions get replicated, it can have situations where the partition is not fully replicated. So usually the way it works is all writes and reads go to the primary, to the leader of the replica. Okay? All writes and reads. So all the work is being done by the leader. Okay? Then the replication process kicks in. So whenever is a write, the replica fetcher thread reads the offsets. There is a protocol with a high watermark. Okay, the high watermark basically is the level where a consumer can actually read. Okay, on top of the high watermark, the consumer cannot read. When all ACKs and mincing replicas are copied over, a positive response is sent back. There are situations, like for example, when you bring a new broker in or you are doing a rebalance of a partition, that under-replicated partitions might be normal. But if you have under-replicated partitions, something wrong can be happening. Okay? So it works usually as a canary. Okay? It may be okay-ish, but it may be situations where this is wrong. This is how you, with a command line, this is how you see an under-replicated partition. You can have a minus under-replicated partitions. Basically, what it tells here is, for example, for this partition, the partition number 0, the leader is the partition number 1. You have 3 replicas, 1, 4, and 2, but only 2 and 1 are in sync. Okay? So replica number 4 is not in sync. Okay? This shows you the under-replicated partitions. Again, remember, if this happens, might be something reasonable, but if this happens, might as well be something problematic in your cluster. Again, remember that. Okay? If this thing, for some reason, is having problems, I will have under-replicated partitions, because the brokers cannot do that. If this cannot write to disk, no, a lot of different situations can happen here. This is actually a real-life example that I work. The scenario is very simple. So you start seeing an increased number of under-replicated partitions. Even, if you remember, some topics might be offline. You stop the producers. The cluster does not heal. You restart the problematic nodes. Everything works again. Okay? However, after you start the producers again, your cluster goes back to have under-replicated partitions. And you start thinking, what might be happening? What was happening here is in a Kafka 0.11, they had a Kafka 0.11, the network and I/O threads were normal. Okay, so remember the diagram that I showed you before? The threads were normal. The issue didn't heal by itself. Okay? So the situation of under-replicated partition, remember, it can be a transitory thing. You will see in the log this out-of-range exception, okay? Or this fatal replica fetcher cannot, because log truncation is not allowed for a partition. What was happening is that we hit this problem, Kafka 5634, that basically it was a problem with the high watermark level growing higher than the log offset. Okay, so we tried to retrieve data that was not possible to be retrieved. As the high watermark were broken, even if you restart the node, the problem was still there. So the only solution to fix that was to upgrade your cluster, the cluster. Challenge number 3. I guess if you run a Kafka cluster, this question has been popped to you like 1,000 many times, is keep ordering. Okay? I want to produce and consume data in order. Does this sound familiar? Your producers are sending message to Kafka without any problem. Your consumers are processing the messages not in the expected order. This could happen for many reasons, so you start thinking, what might be happening? There is many moving parts in this slide that Pere showed me with consumer, producers, etc. In Kafka, remember, the Kafka only guarantees the order per partition, okay? So only guarantees the order per these logs, where the offset is always monotonically increasing, okay? What it basically means is you need to play with this in order to keep order. To produce the messages in order, okay? Remember what we do. We write always to the leader of the partition. This is the relevant variables that the producer have to deal with data. Remember, we have retries, we have batch sizes, we have lingers, and we have one that is very important, or two that are very important. The retries and the max in-flight requests per connection. Okay? First of all, please keep the retries. Okay? The retries are there in order to help you heal problematic situations. Then, in order to ensure that the production is being done in order, you need to tweak the request per connection. Okay? Because if there is 5 requests going on flight, in flight per the same connection, one might succeed, but the other not, and then have a retry. Okay? Obviously, this comes at a cost. Okay? So if you have only one less batching on the number of requests that go in flight, this comes at a cost for you. And as well, another very important point, you should understand your keys. Okay? Remember that Kafka keeps the order per partition, so the key is a nice element in order to ensure which data goes to which partition. So now you might be wondering, this is a distributed system. Have I missed any important part? Yes, the consumers. One thing is writing data, another thing is consuming the data. Your system can have one or more consumers. They are grouped, remember, into the consumer group. Okay, there is tooling to check the consumer group behavior. Consumers are responsible of committing the offsets. Okay, so it depends when the consumer is committing the offset. This message is thought to be consumed. Okay, imagine the situation where one consumer is taking an hour to process a message. So maybe another consumer that's fetching this message as well. Remember, committed offsets are not going to be processed again. The committing messages at reading, so just right after the poll call, where I get the messages, is different than committing the message after the manipulation, or that, like you have done your business logic with that. There is as well something that's called the auto commit. Okay, this works with a timer. If you use it, please understand, like this works as a timer. And remember that the consumers only read until the high watermark level. So you are wondering now what I do. When do I commit my offsets? Okay, understand the pros and cons of enable auto commit. Okay. The enable auto commit works with this timer, so it will commit the offsets every now and then, and it's configurable. It has pros and cons, obviously. Commit offsets when messages are proceed. Okay, when message, always try to commit the offsets, when you are done your business logic with it. And last but not least, if your target system, your destination system is offline, you get the idea of a dead letter queue. Okay? So if I cannot write to a database by my consumer, should keep the message, put it into another topic that I'm going to deal with it later on. Very important as well, embrace at least once. Okay? Think that with at least once, it's going to happen. Even if it happens only when I do reprocessing or when I do disaster recovery, embrace at least once. Prepare your applications to be at least once ready. This one here, like the commit aggressively, might sound surprising, but way too many people is doing it. Okay? Just think, committing aggressively does not give you exactly once semantics. For exactly once semantics, you need transactions, and there is a specific functionality in Kafka to handle that. Okay? And as well, if you commit aggressively, there is a huge amount of load that goes into Kafka for nothing. Challenge number 4, partitions reassignment. Okay, we write to the leader. If we get 1,000 leaders in one node and no leader in the other node, all the traffic is going to go to the partition leaders. Okay, we need to have an even number of leaders into each broker, so the load for each broker stays evenly distributed. Another scenario. Does this scenario resolve to you? Your expected consumption throughput is degrading. So people is calling you. I used to consume this amount of messages. Now I don't do it anymore. Your production throughput is going down as well. So you decide to create new partitions. Why not? One possible scenario. But the problem seems to stick here. Okay? What's happening here? Okay, I created new partitions, but all my leaders, the blue ones, are staying in Kafka broker number 1. So all the load is going to be here. This poor guy, Kafka number 2, is doing nothing. Okay? Why is doing nothing? Because I need to move these leaders to here and bring a few of these followers to here. Okay? And this is a partition reassignment. So the throughput is low. The natural reaction to this situation is I add a new broker as well. And then I reassign the partitions. You have a tool, the Kafka reassign partition tool. However, this scenario done like the Spanish way, it doesn't work. Okay, because you can overwhelm your cluster. Remember this nice image that I showed you? Your network processors can be crashing it. And if they are doing reassignment, they are not serving your normal partitions. Your normal partitions, sorry. Okay? So this process needs to be throttled. Please do that. Okay? I've seen people killing a Kafka cluster because of that, especially in the old days when they could not throttle the process. In the new versions, this process can be throttled. You just need to do it. So the solution for this is always when you do a partition reassignment, try not to reassign the whole cluster. Okay? Do it shtuk by shtuk, no? Step by step. Try to get a small amount and be moving them. Take advantage of replication throttling. Always think to be gentle to the rest of your business logic who tries to still fight for resources. You can use tools as well like Confluent Rebalancer that automate all of this for you. The moral of this is monitor your JMX. Monitor your cluster. You have JMX for that, okay? And as well, another moral of this is when your data flow changes, okay, test it. Again, the Spanish way doesn't work quite well here. You need to test your changes before. That's another indication that you should have like many clusters. You have a pre-production cluster and a production cluster. So, challenge number 5, Zookeeper. I've talked quite a lot and quite fast. I hope you are not sleeping. Question about Zookeeper. How many of you like Zookeeper? Well, someone is laughing, so you have the same experience as me. Funny. Zookeeper is sensitive. It's sensible. You need to take care of Zookeeper. And in Kafka, as it uses Zookeeper, is a good recommendation to take care of it. Okay? It's used as a coordinator to make decisions. Who is the leader, who is not the leader, who is being the controller of a cluster, etc., etc. As well, it's an internal key value store. If you know Zookeeper, Zookeeper doesn't implement Raft or any other algorithm. It uses the coordination among the writes in the key value store in order to make the coordination happen and the election happen. Okay? In Zookeeper, Kafka stores, for example, things like the mapping of the replicas. Okay, so where each replica is living, who is the leader, etc., etc. As well, the topic configuration. So imagine, if you lose Zookeeper, you cannot let Kafka know where each replica is being held. Okay? Just as I give you an example, that data loss in Zookeeper might result in a lot of trouble for Kafka. Another very interesting question here. How many nodes should I use for my production? Zookeeper needs actually not just Zookeeper. Every human that tries to do an election needs an even number of nodes to make that election happen. Because if there is only 2, we can reach an agreement, but we can all vote different things and who remove the draw. How many nodes should I use for production? 3 or 5? 7? 9? The ones who use Kafka in production more than 3 nodes, how many nodes do you have for Zookeeper? Don't be shy. 3? Good. 1 can die. So you are not that bad. Anyone with 5? Good. You are doing the good job. For production clusters, please use 5. Why I'm saying that? Because if you have 5, 2 can die. Okay? And if 1 dies, you are still good. Okay? If you have 3 and 1 dies, where is the quorum? Gone. Okay? Use Zookeeper with a dedicated hardware. This is ideal. And if you can, use SSDs, and dedicated disk for the transaction log. Zookeeper is very sensitive to the latency to write to disk. And that's why I was saying that Zookeeper uses the protocol to do the replication of the key value store to make the elections. Okay, it needs to write things to disk. If you are worried to have way too many data, use the auto-purge functionality. You might be thinking as well, how much memory should I give Zookeeper? Should I give Zookeeper 30 gigabytes of RAM? With 8, used to work very well. It's not a memory-intensive application. And what you should ensure is that nobody's competing for CPU with Zookeeper. Again, the best case scenario, a cage, with button with like algodón in Spanish. I don't know how to say. Sorry, cotton. Yeah, with cotton. Thank you. Nobody's competing with it, because it's latency sensitive. This is a quote from a colleague of mine at Confluent in France. I cannot read French very well, but it basically says, Zookeeper is like your grandmother. At least in Spain, we take care of our grandmothers because they cook very well. And they take care of you very well. You put it in the fireside, you pamper it, and you put SSDs. Okay? Very important, you put SSDs. They are not that expensive these days. Okay? Again, this is a subtle message for the ones who are thinking to use Zookeeper over a NAS. Okay, a network attached storage. Again, remember the latency. It's always funny. Another challenge for Kafka, monitoring. Someone running Kafka without monitoring? Be brave, don't be shy. I know a few of people who run Kafka without any monitoring. No? Good, you at least know what you do. Some sarcasm alert, if someone don't get the sarcasm. An agreement in the community. Running distributed systems is easy. No need to do half observability. The system is doing good. We know what we are doing. We don't need monitoring. Sure. The reality is, without observability, your eyes into the system are blind. If you don't look what you are doing and how the system is behaving, you don't know anything on the system. A distributed system is formed to way too many parts, as we saw in the beginning, so way too many parts can fail. And Apache Kafka likely is a very chatty system. It exports a lot of information over JMX. You have a huge detailed list of metrics in the Apache Kafka site for monitoring. And please, you can inject your monitoring. Have a good monitoring, pull the JMX, but need to have alerts as well, okay? Pulling all your monitoring and having no alerts doesn't work. You should set alerts with different thresholds, okay, to react to situations. And as well, another very important topic that still way too many people forget, you are monitoring Kafka, but you should monitor as well CPU, disk, I/O. Works? Yeah. CPU, disk, I/O, and file handlers. Okay? Because if you don't have enough file handlers, the broker says, I'm going to die. Recommendation for alerts, unless this is what I used to do always or what I used to recommend, 60%, you have some time to react. Okay, you get a buffer of time, 80% run. Run because trouble is coming. A lot of interesting metrics, as we said. We had message in per second. We get the number of requests per second. This is very interesting to understand your load. Under-replicated partitions on JMX, very important, should be always 0. But as we know, may not be and might be reasonable. Maybe more than 0 and maybe a problem. This is very interesting one, the election rate time in milliseconds. If there are a lot of elections of partition leaders, as well, something wrong is happening. The average fraction of time the I/O threads are idle. Again, to monitor this nice image that we saw earlier. Yes, message. Well, another very interesting one is the message. The time spent in message conversions. Okay, if you're doing rolling upgrade, there's going to be message conversion. So you need to monitor that, and you can do that. A lot of information is there. So the recommendation is go to the documentation and read about it, and it's going to be very important for you. Pull these metrics into a central solution like Elasticsearch, Solr, etc., and set alerts. That is nice tooling that do that for you really nearly out of the box for everything. Prometheus with JMX Exporter and Reporter in Grafana. You get Jolokia, Metric Bit, and Elasticsearch is another extremely common solution. If you want more details, this is a small example of how to use monitor Kafka with Prometheus, or a nice article on how to use Metric Bit with Jolokia from the Elastic website. Again, use monitoring. It's not bad. If your boss tells you you don't have time for that, tell him what's going to cost more, broken Kafka or no monitoring. Another challenge is security. With security, it's always like monitoring another non-just gentleman. If you are willing to really screw things up, don't put any security, okay? By security, I mean security and quotas. Remember the nice image we saw before? Everybody's competing for that queue. Everybody. Replication and clients. Apache has support for encryption authentication over SSL. You can do authentication with SSL. You can do authorization with ACLs. And very, very important, you can do quotas and throttling, okay? For produce and fetch requests. Kafka uses the JAS mechanism to configure security. So if you are a Java developer, you know what to do there. Very, very useful for multi-tenant deployments, okay? As we are all here building microservices and multi-tenant installations of Kafka, encourage you to use quotas and throttling. Because at the end, you need to provide enough food for all your customers. You can use SSL to communicate between brokers as well. However, this is not the most common scenario. You have your brokers communicating over plain text because they're into a secure network, and from the outside, you communicate over SSL. SSL. You can do authentication with SSL, with Kerberos if you know what you are doing. Don't underestimate Kerberos. Really? Another common problem, people underestimate this beast. You can do OAuth beater. unless you know what you are doing, don't do it in production, okay? It can work, but it's, like, you need to know what you're doing. For Scrum, credentials are stored in Zookeeper. Again, another reason to protect our dear Zookeeper, okay? And plain that uses password over TLS. Remember, you can have more than one mechanism at the same time, okay? So you can have different listeners working in different ways. And in the new version of Kafka, you can even have a separate plane for data and for controller. So the load is separated quite much. And as well, there is even an LDAP integration by Confluent. Okay, so if you work in a company that have LDAP and still have to suffer Windows, you can use integrated with LDAP. Nice things about ACLs and quotas, as I said, remember to leave small resources and enough resources for every of your customers. If you get one that is busy and greedy, it can get everything unless you cut him down, okay? Leave enough food for all your dinner guests. You have use quotas is basically a byte rate threshold, okay? You move data from cluster to cluster, use throttling, your cluster will appreciate you, okay? By your cluster at the end, all your customers. Success with Apache Kafka. Understand guarantees and durability. Understand if I don't want to lose messages, or understand if I'm just doing clicks on a website, and if I lose 5%, I don't really care, okay? This is a very important point. Get comfortable with the way replication mechanism works. Because most of the time when you say I'm losing data, it's because the replication mechanism was not well understood. How to handle message ordering, okay? Remember, per partition. So I need to sort out how to use my keys, how to consume them, commit offset, etc. Load balance your data access, okay? Remember, the leaders needs to be evenly distributed. Very, very important, take care of our beloved Zookeeper. He's an old guy with a red dot in the head, and yeah, needs to be taken care. And as well, last but not least, please, use monitoring and security and quotas. It will help you sleep at night. If all of this sounds terrible, like your worst nightmare, consider using a cloud service. For example, Confluent offers one, okay? If you can do that with your eyes closed, hopefully open because you know what you're typing, we are hiring, okay? So talk to me. And I'm 5 minutes for questions. I made it on time. I was trying hard not to stop talking. So
anyway, any questions? Okay, over there.
Don't be shy. Yeah.
Hello.
Yeah.
Thanks for your talk. So, like coming back to consumer side. Yeah. So coming back to that like committing often is pointless and it just produces load on Kafka. So does like getting a bunch of messages, like 10 messages and then committing, sound like a sane approach, or it can cause some issues or something?
The thing that is, so the question was about the trade-off of auto-commit and committing often being a bad practice. The point that I said is that these people committing often in order to get exactly once processing. This is not like this. So committing off, how often you commit is a decision you have to make. The thing you have to understand is that as soon as you commit a message, it's being dealt with, it's being proceed. Okay? If this offset is not committed, it's not finished the consumption of this message. So for it's always like, I don't like to say that word, but it depends. You know what I mean? At the end, it's important to say that, like you commit an offset, it's being dealt with, it's being consumed. No offset committed, no consumption happen. More questions? headaches, already sleeping, it's second day.
Hi. Do you have any plans, public plans, to finally get rid of Zookeeper?
Zookeeper is like an old man with a red dot in here, because someone is like trying to shoot him for a long time. The community is discussing about that, but I don't know what's gonna happen.
Or at least make it pluggable, like etcd Zookeeper, what Banzai did, let's say.
You can follow the keeps in Apache. Every discussion in Apache Kafka is being done in the open in the Apache community. So that's the best advice. More questions? Don't be shy. You can as well grab my neck afterwards. But.
Okay, I think no more questions.
Nope, we got time. I got in time. No?
Okay, thank you very much, Pere.
Thank you.